All right, folks, Mr. Bucko here with example 3 from our 4-3 algebra lesson on solving systems of equations with elimination. So we have our word problem of the day here. So we have a florist, that's somebody who puts flowers together, is making regular bouquets and mini bouquets. And the florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make with these amounts of flowers? 118 roses, 226 peonies. And the criteria is that a regular bouquet has 5 roses and it has 11 peonies in it. And then a mini bouquet has 3 roses and 5 peonies in it. So if that's the criteria from which this florist is working, how many of these baskets of each can they make if there are 118 roses and 226 peonies? And the one thing that we want to keep in mind here that might be an oversight is that we want to use all of the flowers. Because obviously we could say, well, we could make just 2 of each easily, but we want to maximize that amount and use all of the flowers is where we're going here. So that might be something that could easily be overlooked and just think, well, it could be 2. Just make 2 of each and then we're done. And that's not exactly what we're looking for here, because then we wouldn't use all of the flowers. So what we want to do here is set up a system of equations. Is what we're going to do. And we need to do that by finding out, well, what are our variables here? What are the values? What are the numbers? What are the things that we don't know that we want to know? And what we want to know here is how many of each type of bouquet can the florist make? Well, the florist can make regular bouquets, and the florist can make mini bouquets, and we don't know those values. Those are our variables. So we're going to have a variable, let's call it R. R will represent how many regular bouquets we're going to make, because we don't know what that is at the moment. And then M can be how many mini bouquets. And I could use X and Y, but I'm going to use R and M just for the sake of making maybe things a little bit simpler, just knowing what each variable stands for. So R will be how many regular bouquets we make. M will be how many mini bouquets we make. And we know that in each regular bouquet, we use 5 roses and we use 11 peonies, and each mini bouquet uses 3 roses and 5 peonies. So the equations we can come up with here look like this. So we have 5 times R plus 3 times M is 118. This comes from the roses. We take 5 times the amount of regular bouquets we make, because each regular bouquet has 5 roses. We're going to add that to 3 times the number of mini bouquets we're going to have, because there are 3 roses in each mini bouquet. So these tell us how many roses we're going to use. That needs to be equal to 118, because the florist has 118 roses. So that's what this equation represents. It tells us how many roses, or how many regular bouquets, excuse me, the R stands for regular bouquets, and how many mini bouquets we can make with the 118 roses if we use 3 in a mini bouquet and 5 in a regular bouquet. The bottom equation represents how many peonies we're going to use. So there are 11 peonies in a regular bouquet, so 11 times R. So for every regular bouquet we're going to use, we're going to multiply that by 11, because there are 11 peonies in each regular bouquet. And there are 5 peonies in each mini bouquet. So take the amount of mini bouquets we're going to use, or 5 peonies in each mini bouquet, and that will tell us how many peonies we'll use in that one. And that has to be equal to 226. Why? Because we only have 226 peonies. Here's our system. We want to solve for R, we want to solve for M, we want the R and M that works in both of these equations, because this is telling us how many of each flower we have. They're both in standard form. The R's are lined up, the M's are lined up, equal signs, constant terms here. But if we were to add these equations together, neither variable, R or M, are going to go away, because 5 plus 11 is not 0, and positive 3 plus positive 5 is also not 0. So we have to manipulate one, or in this case, both of these equations, because we want these numbers to be opposite. So we kind of want this 5, ideally, to be a negative 11. Well, we can't multiply 5 by anything nice to get negative 11, and that's going to give us a decimal, and that'll be kind of a mess, so we're not going to do that. We want the 11 to be a negative 5. We're going to have to divide by not a nice number, so that's not going to work. We want this positive 3 to be a negative 5, but positive 3 doesn't really go into 5, so that's not going to be helpful either. So what we're going to do is we're going to multiply both of these equations by a value to get those opposite coefficients. So here's what I'm going to do. I'm going to take the top equation, and I'm going to multiply the top equation by negative 5. Because that'll change this to a negative 25. It'll change this positive 3m to a negative 15. And then it'll change this 118 to 590, I believe. We'll see in a minute. That'll change the negative 3, or the positive 3 to a negative 15. Then I want this positive 5 to be a positive 15. So to make a positive 5 into a positive 15, I'm going to multiply the bottom equation by 3. So I'm going to change each of these equations and I have to multiply the whole thing by that value. So when I do that, I get this equation. The equation right here is the top equation multiplied by negative 5. Negative 5 times 5r, negative 25r. Negative 5 times 3m, negative 15m. Negative 5 times 118, negative 590. Negative times positive is a negative. That's the top equation that's been changed. I multiplied everything by 5. I'm going to take the bottom equation and multiply everything by 3. 3 times 11r is 33r. 3 times 5m is 15m. 3 times 226 is 678. So these two equations have been changed to these two, both in standard form, but now what's nice about these two is that opposite coefficients. Opposite. So when I do negative 15m plus 15m, I get 0. So I can add these together. When I do that, I get 8r equals 88. 8r comes from negative 25r plus 33. 8r. This equals 88. 88 comes from negative 590 plus 678, or 678 minus 590 is 88. The m's are gone. Why are the m's gone? Because they canceled out. Negative 15 plus 15 is 0. So 8r equals 88. Well, if 8r equals 88, r has to be 11. So we're going to make 11 regular bouquets. This r is 11. Either r is 11. So I can find out what m is now by taking this r that is 11 and plugging it in for either one of these equations here. I'm going to pick, it looks like I picked the top one. I picked this one right here. 5r plus 3m equals 118. So I picked this equation that I started with here, and I replace this r with 11. Why? Because r is 11. So 5 times r, that is 11, plus 3m equals 118. Do the algebra, do the arithmetic, order of operations. 5 times 11 is 55. So 55 plus 3m equals 118. Subtract 55 on both sides, and you get 3m equals 63. And if 3m equals 63, we divide both sides by 3 and get m is 21. So what this means is that we can make 11 regular bouquets, 21 mini bouquets, and use all of the flowers that we have because they'll work. 11 and 21 will work in both of these equations. And there's our answer.